Chapter 1.3 is about real numbers. Before getting to the meat of today's work, first thing I want to do is look at a new type of process we're expected to understand. We've experienced the first type of number but not really officially called it by its name. The square of a number is found by multiplying it by itself. So if you're asking for the square of 3, that means do 3 times 3 and you get the answer of 9. If you want to know what the square of 10 is, it means do 10 times itself and multiply to get 100. In other words, it's the power of 2. So if the square means multiply by itself, then the square root means what number multiplies by itself to make it. So it's the opposite of a square. So if the square root of 9, you're looking for the number that multiplies by itself to make 9, which is 3, because 3 times 3 is 9. If you're looking for the square root of 100, that means you want the number that squares to make 100, which is 10. So again, the square root of a number is found by identifying what multiplies by itself to actually make that number. So squares and square roots are important. The notation for square roots is this here. So this means square root of 16, which means think of a number that multiplies by itself to be 16. To me, that number is 4. So the square root of 16 is 4. Square root of 25, again, that's how you read that, means what multiplies by itself to be 25. From what I know, 5 times 5 is 25, therefore your answer is 5. It even works with fractions, but what you do with fractions is you separate it, and then you do each part. So square root of 4 is 2, square root of 9 is 3, which means the square root of 4/9 is 2/3. Alright, so part 1 is just making sure you understand the square root notation. Part 2 is what we're really here for. Real numbers are numbers that actually exist. These are all different number types. So real numbers is one type. Real numbers are numbers that actually exist. Every number in this chapter is a real number. We will not expand you that far just yet. Our job is to classify each type of real number that exists, and right now there are 5 that must be considered. The first type of real number is what we call a natural number. A natural number is a number you use to count naturally. And so when you think about naturally counting something, if you were counting the lines in this page, you go 1, 2, 3, 4, 5, 6, 7, and so on. So notice 1, 2, 3, 4, 5, 6, 7, all those would be natural numbers. Those 3 dots, I believe, are called ellipses, and what they mean is that the pattern continues in that direction. But other than that, natural numbers 1 through 4. Whole numbers. The way I think about whole numbers is natural numbers with a whole in it. In other words, a 0. 0 would represent a whole, so a whole number starts at 0 and then it counts all your natural numbers from there. So the difference between natural numbers and whole numbers is that the whole numbers have the whole, the natural numbers start at 1. Integers are positive and negative whole numbers, which means take all these numbers in this list, put the negatives on this side, the positives on that side. So that means that it goes from negative 1 million up to negative 3, negative 2, negative 1, and so on, all the way up to 1,000,000, but there are no fractions or decimals inside of anything we've talked about yet. That doesn't show up until we get to rational numbers. Anything that's a decimal or a fraction, anything that's a decimal could typically be either rational or irrational. Rational numbers fit inside of what I call a box. So what I mean by that is 0.2 is rational because I can fit it here. 3/5 is rational because I can fit it here. Negative 9.3232, there's no dots, which means that number stops. Check it out. I can fit that into a box. Negative 6, even though it's an integer, I can fit it into a box. 0, if you remember, is a whole number, but I can fit it into a box, so it's also a rational number. 9.6 repeating, even though that would go on forever, the fact that I can use repeating notation means that also fits into the box. Irrational numbers do not fit into a box because they're not rational. That's what irrational means. Square root of 5 is an ugly number. I don't have my calculator, but I do have a calculator. And the way you know it's irrational is because when you type the square root of 5, let's see, you get a number that fills the screen. Whereas if I do square root of 225, I get a nice number there. Or, let's see, if I did the square root of 20.25, as ugly as that might be, notice how the number fits. So if the number goes all the way out to the edge of the screen, it's probably irrational. E is any number that's so ugly that it has to be simplified down to a letter is irrational. Anytime you have a decimal that has 3 dots with no pattern, it's an irrational number. So again, that's what you're thinking about here. So how do you make sense of each type of number? Study the notes, learn the common sense connections that I just gave you, and then ask yourself if it makes sense. So here we go. Do you naturally count things and get to 2/3? No. Do you naturally count? No. Integer? No, because remember, no decimals or fractions here. Rational means it fits in the box. Does this fit in the box? Yep, which means it's not irrational. It cannot be both irrational and rational at the same time. 13. Can I count to something and get 13? Yes. Is that a whole number? Yes, which means no decimals, no fractions. Integers are also whole numbers. Yes. Is it rational? Does it fit in the box? Yes. Cannot be irrational. That's what you're doing. And there are some questions on your homework that are asking you to pick everything that it is. You do not count negatives in natural numbers. There are no negatives in whole numbers. There are negatives in integers. And does it fit into a box? Yes, which means it's not irrational. So that would be your options there. Square root of 15. I can't think of anything that multiplies by itself to be 15. First off, it's not natural, not whole, not an integer. And even though that fits into a box, if I were to type square root of 15 into a calculator, it's a long, ugly number because it should be a nice number, which means that it is irrational. It's like that part I typed into the calculator. Square root of 1. Is there a number that multiplies by itself to be 1? Yes, that number is 1, which means the first thing you probably want to do is simplify it. That means it's natural, it is a whole number, it is an integer, it is a rational number, it is not an irrational number. Okay? So again, that is the process that you are going to use when you think about this stuff. Pi. I said anytime you have to minimize a number down to a symbol, it means that it can't be any of those things. It's an irrational number. People are still trying to figure out a pattern to pi. It doesn't exist. There's one more topic that must be briefly discussed. You will be asked to put numbers in order from smallest to greatest, or least to greatest. Just think of the number line. The number that is the smallest is the biggest negative. So negative 10 is smaller than negative 9, is smaller than negative 8. Anything on this side is small, that side is large whenever you compare numbers. Holds for every negative number. The biggest negative is the smallest value. You'll typically see multiple choice questions, so we will look at using common sense to answer them today. So we'll look at the other strategies later. The general rule is that all values can be converted into a decimal. Before ordering anything, convert every number in the problem if necessary. So if I were asked to order these numbers from least to greatest, I'm not going to use a calculator because I don't think I need to. 1 over 4 is 1/4. That's about 0.25. So I'm going to kind of change that number. Negative 2 is good. Negative 8, square root of 8, I don't know what the square root of 8 is, but I know that 2 squared is 4. I know that 3 squared is 9, which means that it's going to be pretty close to 3. So I'll just say because square root of 8 is pretty close to the square root of 9, I'm going to say this is about 3, just for now. 7 over 2, if you remember changing improper fractions, 2 goes into 7 3 times with 1 left over, so it would be 3 1/2 if you were to convert that. And then 1.3 is already a decimal. And so when you go to do this, if you're going from least to greatest, remember that negatives are the smallest numbers. And using your common sense here, it cannot be A, because there's no way that 1/4 is smaller than negative 2. Which means it's either B, C, or D. Now, let's compare negative 2 to negative 3.5. Well, based off what I know, the bigger negative is smaller. In other words, debt. I would rather owe someone $2 than $3.50. So this is smaller, which means it also cannot be B. And if you look at the rest of these, that matches, that matches, that matches. So it comes down to this. Square root of 8 is 3 about. 1.3 is smaller than 3, which means that should be the biggest one. And so you'll want to kind of think your way through it. Otherwise, again, it will not work. But every question that you have on there is going to be a question that you can kind of gauge what's going on. If you have to use a calculator, feel free. Again, I cannot force you not to. And because I can't force everybody not to use a calculator, I'm not forcing anyone to not use a calculator. So just have as much integrity as you can when you do this stuff. But in order to classify a number properly, you must check the qualifications of each type. That means you actually have to remember the types of numbers and what makes them special. Natural numbers, whole numbers, integers, what was the other one? Rational numbers and irrational numbers. Here's your notes I'm going to put up here for about 3 seconds and pause. Other than that, make sure you answer the question at the very end of this video, and that is it.